Bismillahirrahmanirrahim. Dear student, hope you are fine, good, and great. Now we are going to study the Newton law of motions. We have in this chapter we are going to just three law of motion. Newton have more law, but we will focus just on the three law of motion, like Newton first law of motion, Newton second law of motion, the Newton third law of motion in this chapter. And in each law there must be we will study, or there must be a force will happen, or there must be a force in every law. So let's see the Newton first law. What is this in the Newton first law definition? So simple, just listen first. Newton first law say that if the object is at rest, let's suppose this object is at rest, so Newton say that this object always remain at rest if there is no other external force act upon. uh, what do you mean by the external force? Like the gravity force, air resistant force. So if we remove these all types of forces, so this object will always remain in the rest. Like let's suppose I put the marker here. So this is in rest, so if I do not disturb this marker, so it always remain in the rest. Okay, this is the first part of the Newton first law. The second part, Newton say that, for example, if we apply some force on the object and there is produced some motion on the object, this object produce like start the motion. So Newton also said in the second part of the first law, if this object start the motion, Newton said that this object will always be in motion. So until if the unbalanced force act upon on it. Unbalanced force mean, again, like let's suppose if we throw a ball like this one, after some time it is coming down to the ground. So why? Because of the gravitational force and also because of the air resistance. If we remove these types of forces like gravitational force, air resistance, and other forces, so this object will always be in motion. Okay, let's see the definition. Newton first law is often stated is an object is at rest, stay at rest. The first one, like this line, clear this part. The object is at rest, is at rest, and object is in motion, stay in motion. This is the second part, with same speed in the same direction acting upon by an unbalanced force. So again, I want to say the Newton first law is two part. The first one is that, like, if the object is at rest, it is at rest, so it always be at rest. And if the object is in motion, so it always be in motion until if there is no unbalanced force act upon on it. And remember, the total force in the first law will be equal to 0. Okay, the in Newton's second law of motion say that, let's see the definition. The second law of motion states that the acceleration of the object directly proportional to the net force acting on it and inversely proportional to the mass. Let's see here, Newton said in the second law, if we have the object, some object have some mass, so if we apply the force or on this object, so there is produced some acceleration on the object. So when the acceleration is increase or when the acceleration is decrease, so it's very simple. If we increase the force, like here is I apply the 5 Newton, in the second case I apply the 10 Newton. So let's suppose I increase the force, I mean here is 5 Newton, here is 10 Newton, so definitely here is produced the more acceleration and here is produced the less acceleration. Why? Because the force is less here and here is the more force. So Newton say, he said acceleration of an object directly proportional mean that if we increase the force, so the acceleration is also increased. Or the second case, if we increase the mass, so it is inversely proportional. Like if here is 5 Newton and here is let's suppose 10 Newton, sorry, 5 kilogram and 10 kilogram. So if we increase the mass, so the acceleration is decrease. So in Newton's second law say that in Newton's second law, a very famous formula, you know, F is equal to ma, which is equal to Newton. M mass time acceleration is equal to Newton. So again, let's see, Newton is in the second law state that if we apply the force on the object, so there is produced the acceleration. So this is acceleration is directly proportional to the force but inversely proportional to the mass of the object. Okay, let's see the third law. In the third law, Newton third law formally states that for every action there is an equal and opposite reaction. What does it mean? Newton said that if we perform some action, so there must be the opposite reaction of our action. Like how if we firing on the pistol or gun, so if we fire first, the pistol apply the action like reverse and then go forward. So this is action and this is reaction. The second example, like if we throw a ball on the wall, so our if we apply the force on the ball, so it will hit the ball, so our force is action, so the ball is reverse, this is called reaction. So the another example, consider how we walk. Like if we are walking on the floor, so our foot or our shoes apply the force on the earth, so the earth, like this is our shoes, so it will apply the force on the earth, but the earth also apply the force on the shoes. So the shoes force on the earth is action, but the earth force on the shoes is reaction. So this is the Newton third law of motion. Okay, let's see the some application of the law of motion. Like application mean these law are normally used in our daily life in different ways. Like the first one is normal contact force. What does it mean? That like the normal contact force, this is the very important, and we will use the normal contact force. And the other one is tension force on the next page, so which is used and usually asked in the question. So inshallah next video you will see that how we use like what is normal contact force. A normal contact force is a force exerted on the surface. It is also called the normal contact force. Like how again here in normal contact force there is the action and reaction. Like if we apply the force on the wall here, so the wall also exert the force on the hand. Like let's suppose I put the hand on the wall and I apply the force, so the wall also apply the force on my hand. So this is hand force, and the wall this apply the force on my hand, so this is the normal force. And what is contact mean these two are touched. And one thing always remember, the normal contact force is always perpendicular to the surface. Here is the another example. Let's suppose there is the object which are placed on the surface, like this is the table. So it that object have some weight on the surface of this table, so the surface of the table also apply the force on this object. So this is weight and this is normal force, so these both are in contact with each other. And normally we say in the second thing, this will always be perpendicular, the normal to the surface of the object. And also we say normal force is always equal to the weight. Okay, so this is called normal force or normal contact force. The last one is which is the application of the law of motion is the tangent force. Now what is tangent force? One thing remember, tangent force is found in the rope. Mean like let's suppose this is the rope. If we hang this ball, or let's suppose this is the lamp, so the lamp is apply the downward force which is weight, and the rope of this which is hanging this ball or this lamp, so there is another force is also produced. This is called tension force. Like all types of chain forces, spring forces, this rope forces is called tension forces. Let's see what is the definition here. When an object is pulled by a string mean this wire, this rope, this spring, this is called any types of string. The string exert a force on the object, like this lamp is apply the force downward, but the rope or chain apply the force upward. So this is action and this is reaction. So again we use the third law of motion or third law of Newton. And also if we have a spring, if we put the spring here, so again the spring apply the force upward, but this object is moved downward, so this will be equal, and the object will at rest. So again here is action and reaction is happen. So let's see again the definition. When the object is pulled by a string, the string exert a force on the object. Such types of force of the string is called tension force. And we will see the example, like mathematical example we will show. Like let's suppose here we have a simple example. For example, 5 Newton is applied on the object. In the object mass is 5 kilogram. This set usually asks find the acceleration. So we know that if is equal to, here the Newton's second law is applied. The Newton's second law is m time a, mean mass time acceleration. So force is 5 Newton and mass is also 5, but acceleration is unknown. So acceleration will be equal to 1 meter, or we can write 5 Newton over 5 kilogram. So 5 divided by 5 is equal to 1 meter per second square. So this is also one of the example. Like we can inshallah solve this types of example in the next video. So be stay with us. Don't forget to subscribe the channel. Just watch our video. Thank you so much for today lecture.